Hello everyone, in this video I'm going to show you how you can use KiCad to create a hierarchical schematic. Now, there are many advantages of doing a hierarchical schematic design. So one of the advantages is that it is easy for you to read the schematic. The second advantage is that debugging becomes easier, and the third, you can easily reuse the components. If you are doing a hierarchical schematic design in KiCad, the components that you are using to build the schematic is easily reusable compared to when you do a schematic design following the classical or the traditional flat schematic design approach. So in this video, let me show you how to do a hierarchical system design using KiCad. So the first thing that you need to do is open the KiCad, create a new project. So let us go to File, Create New Project. Let us call this project Schematic Project. So let us call this Hierarchical Schematic Project HSCH and click on Save. Now open the schematic page. Okay, so you have a schematic here, and let's say, let us first take an application or an example. Let us say you have a USB connector, and which is delivering a voltage. Let us say it is 5 volt. You have to take this 5 volt and generate a 3.3 volt. So that is our example. That is a schematic. We are going to design a schematic for this particular application. So how do you do that? So in the traditional approach, you place the connector for USB B, then you place the regulator circuit, then you place a connector for the output of the regulator to feed the output of the regulator, and you have all these connectors and components right in the schematic. And many a times it becomes easily difficult for a simple project like this. It might be okay, but when the complexity of the project is a bit higher, it become when all the components are going to be inside a single schematic, it becomes difficult to read. So, hierarchical schematic design is something that is useful in such designs, and the complexity of the uh, design is a bit higher. Say there are a lot many components, and these components are interconnected in multiple different ways, and there are many a times components are being reused. So, in such cases, it is always better to go with a hierarchical schematic design. So, how do you do that? Rather than placing the components all together in the schematic, we will place hierarchical sheets. So there is a symbol here for placing hierarchical sheet. And the first hierarchical sheet we are going to place is a hierarchical sheet corresponding to the USB B connector. So let us name it as USB B connector. The sheet file name typically we give the connector part number. So let us say this has a part number of part XYZ. We will change it later because right now we don't know what is the part number that we are going to use. So click on OK. So you have placed a hierarchical schematic sheet, and yeah, this is a sheet. This is a block that is going to correspond to the this is a block that is going to correspond to the USB B connector. Now, what are the terminals for a USB B connector? So when you look at the USB B, the common terminals that you see are the V bus, the ground, the data plus and the data minus terminals. So first let us go and add these terminals. So go inside this block and we need to add these terminals, and the way we define these terminals is using the by placing the hierarchical labels. So click here and place a first label. Let us place it as V bus. Make this bidirectional and click OK. Okay, so we have placed V bus. We need to place ground. So click on here and place ground. We also need to have the terminals corresponding to D plus and D minus. Okay, so we have these four terminals for the USB connector. Now we have, if you note it, we have not even placed any USB connector here. We are just defining the terminals for the connector. Now come to the root page, and now we want these terminals to be visible on this root page. So what you do is right click here and then say place sheet pins. You have this DM here, you have this DP here, and you have this ground here, you have this VBus here. Now, for this particular project, we are not much concerned about DP and DM because we are using this USB-B connector as a power source, which is generating a 5 volt, which is being given to a regulator, and you generate a 3.3 voltage out of it. Okay, so for time being, we would say that the block for the USB-B connector is completed. The next step is you have to create a block for the regulator. So Control C, Control V, you have a block here. Let us delete all of these terminals and go to right click, go to properties. Let us say that this is the 3.3 volt regulator. That is what we are going to uh, name this block. The sheet file name typically is a regulator part number. So for time being, we will keep it as regulator part XYZ. Now let us click OK. Now let us rearrange the shape of uh, the box, and this is a regulator part number. This is a regulator. Okay, so the regulator is done. Now, what are the terminals for this regulator? You will have the input terminals, which is taking the 5 volt and the ground, and you have an output terminal which is 3.3 volt. So let us go inside this block. This block is, since it is copied from the USB connector, it already has V bus, ground, DP, and DM. Let us change it to uh, 5 volt and ground, and then there is an output volt which is 3p3 volt. So 3p3 is the output, and 5 volt and ground are the in 5 volt and ground are the inputs to this block. Now we want these terminals to be available at 3.3 volts. So right click here and say place sheets. 3.3 volt is at the output, 5 volt is at the input, and ground is also at the output. The ground is shared between the input, is shared by the input and the output. The next step is to make the connection. So go to the wire symbol and make the connection. We first to 5 volt and this ground to this ground. Okay. And TP and DM, we are not going to use it, so make it no connection. Okay, so that is done. So we also want a connector to feed in this 3.3 volt, so that if you want to just monitor the output voltage, we should be able to do that. So let us place a connector. So rather than placing the connector here in hierarchical schematic design, we are going to place a schematic symbol. So for timing, let us Control C, Control V here, and we have the schematic symbol. Right click here, go to properties. This is a 2-pin connector. For time being, we don't know the part number, so let us make it as connector part XYZ and click OK. Yes, and we don't need uh, we don't need these. For timing, we will delete these terminals. Go inside this. We don't need 3 terminals, only 2 terminals are required, and one terminal is let us say the one of the voltage that is fed to this connector, and the other one is a ground. Okay, so Vx and ground, and these are the inputs that are being given. So let us position it like this, just for somebody to read it easily. Now go to the root page, right click, place sheet pins. The ground is connected over here, and the Vx is connected over here. Now you complete the wiring. The 3.3 volt is wired to Vx. Now the ground is wired to the ground of the USB connector, something like this. Okay, so your connections are done, and this is the root page or the top page of the hierarchical schematic. It is very easy to read the schematic by looking at this top page. So you know that there is a USB-B connector which is which provides a 5 volt V bus voltage, which is being given to a 3.3 volt regulator, which gives 3.3 voltage as the output, and this 3.3 voltage output is being fed to a 2-pin connector. So it becomes easy to read by looking at this schematic. Now this is how the top page will look like. Now let us look into the details of how each of these blocks has to be further designed. Let us go to the USB-B block. So right click on the USB-B block, and we are going to place the component which is a USB-B connector. Okay, anyway, come here. You can search for the uh, USB B, USB. Okay, so let us say you want to go with the USB B, maybe a micro connector, USB B micro connector. Yeah, so this is what we want. And let us go to the symbol for the USB B micro. Let us select one. Yeah, let us say we are going to select this. For time being, we are only worried about the schematic. We can change the footprint later. So click on here and place it on the schematic. Okay. Now what you have to do is take these hierarchical terminals over here and then complete the connection. So the VBus is going to be directed to the VBus of the micro B connector, micro USB connector, and complete the ground connection. So the ground is going here. Shield is also typically connected to the ground. ID we will make it NOC connection. The DP, let us take the DP and place it to D plus, and DM also let us place it to D minus. So this completes the schematic of the USB B, and since we are using a USB B micro molex, let us take this part number. So we'll take it molex 105017. Okay, just copy this, click OK, come over here, and then right click on the properties, and the file name you change it with the part number. Okay, so this is molex 105017. Click OK. Fine. So that completes the USB P block. We have completed the schematic that need to go into the USB B block. The next thing is let us go to the regulator. So inside the regulator, we need to place a 5 volt to 3.3 volt regulator. So let us go to a regulator. Let us see what regulator we have. 3.3 volt regulator. There are many options here. Let us look at yeah, so this looks like a regulator. There are many regulators available, so you can select the one that you like. Let us select this one. So this is going to give you a 3.3 volt fixed output. So click OK and place it here. And the next thing that you need to do is to, as done before, connect the terminals of the circuit to the hierarchical sheet symbols. Okay, so you have this ground going to the ground of the circuit. The output is going to be 3.3 volt. The 5 volt is going to the both the input as well as the enable. You need to enable this IC so that you get an output of 3.3 volt. So that completes the regulator section. And what we will do is we will copy this name and then label the page accordingly. So this will be go to the properties, and we will change the sheet file name. Okay, so this will be TLV 75533 75533B maybe. Okay, so this is the part number. Yes. Okay, so that is done. Now we need to have a 2-pin connector also. So double click on this and then you go to the symbols and then you go to the connector. So we have a 2-pin connector. Let us go to the connector part. What we want is a connector. So we have a connector here. one cross two pin. This is one option. Yeah, for time being, we'll select this particular connector. Okay, we'll select this particular connector. So we are not focusing much on the schematic. Is there any other connector that is available? Let us look at it. Okay, so let us for time being take this connector and you place this connector over here. Yeah, so it's a two pin connector, and what we need to do right now is we need to connect this to the hierarchical sheet label. So you connected px to here, and to the pin 2 you connected the ground, and this completes a two pin connector. So we have completed the circuit for the USB B. If you look at it, it is USB B. Now go back to the root page. You have completed the regulator 3.3 volt connection. You have also connected the two pin connector. If you want, you can have a hierarchical block, sub blocks inside a two pin connector schematic also. So the level of the hierarchical hierarchy can go deeper and deeper if that is needed, depending on the complexity of the project. But for time being, we will just stick to one level of hierarchy. Come down to the root page. So that is done with the, you are done with the schematic. Now let us do an ERC check. Run the ERC. Yeah, it says there are no errors and warning. It means that your schematic is done. So this is how you create the schematic. You say the schematic. Yeah, so this is how you design a hierarchical schematic sheet in KiCad. Now let me explain you one of the couple of advantages. One advantage is that it is easy to look at the schematic and read it. If there is a mistake, you'll be able to easily correct it. The second advantage is that you can create this root level schematic or the top schematic, and then you can give these sub blocks to your team members so they can look into the schematic of these sub blocks separately. And then once it is done, you can merge them together, and that makes the project manageable. The third main advantage is that let us say you need to reuse these components, it is easy to reuse. Say for instance, let us say that for some reason I want to have one more regulator which is 3.3 volt and which I need to feed it to another two pin connector. So what I can do is I can just uh, copy these two blocks, Control C, Control V, and then paste it here. Okay, so what is the next thing that I need to do? Just make the connections. So how do you make the connection? Go to the wire. The 5 volt would be connected somewhere here, and this would be connected to the ground. The ground here would be connected here. So this completes the design, and you don't need to worry about what goes inside. It is replicated. So if you look at here in this regulator also, you can see the circuit. Here also you can see this circuit. Now coming back here, let us run the ERC check. So when you run the ERC check, it says there is a duplicate item, which is the symbol J3. The reason why it happens is typically because when you duplicate it, uh, there's a possibility that the annotation also remains the same in some cases. So what you have to go do is go to tools, go to annotate schematic, and you have to reset existing annotation so that the KiCad itself do the annotations properly. So let us come here. This is J3. This is now changed to J2. Now let us go and do an ERC check. Yeah, it says no errors and no warning. So that is done. Okay, so this is how you do a hierarchical schematic sheet design in KiCad. And some of the things that you need to take care of when you work on hierarchical schematic design, that is something that I want to explain. So all of these wires, these scope of these wires are within the sheet. And if you go inside this regulator 3P3, the 5 volt that you see over here, the 5 volt label that you see here is also the scope of this 5 volt is within the sheet regulator 3P3V. What does that mean is that this 5 volt is not accessible inside the 2 pin connector. It is not accessible inside the 2 pin connector 1 and so on. And that is a that is how a hierarchical design is constructed. So when you do a programming language which is designed in a hierarchical fashion, each of the files will have a scope. The variables in that files will have a scope and is not something that is being accessed by a different block. So what goes inside this block remains inside that block. The labels remain inside that 3.3 volt. It is not visible to the other blocks. Okay, only if you do the connections, these blocks get glued together. Now, in order to ensure that such a condition or such a system is maintained, we need to take care of something that people generally make a mistake of. So let us say you want to connect a ground. Okay, so instead of connecting a ground directly here, another possibility is that you can place a ground symbol here. Okay, so you have a ground symbol. Let us take a ground symbol and click OK. You place a ground symbol here and you place one more of these ground symbols. You place Control C, Control V, you place one of these ground symbols here. So this connection is okay in the sense that these 2 points are connected together. But the problem is that this ground symbol, or for that matter, any power symbols in KiCad, has a global scope, which means that if you are using this ground symbol in a different block, if you are using a ground symbol in a different block, this ground and the ground over here are connected globally. We don't want to do that. So when you design a hierarchical system, we want these blocks to be independent of each other. We don't want these connections to happen globally unless and until we force these connections to happen in the root page. Okay, so what we should do is we should never have these connections using uh, global power symbols. You should not also use something like VCC. Say, you should not use this particular symbol. So these are global labels which are even accessible outside the blocks. So what you have to do is, let us say that you don't want to have a direct connection here because the circuit is a bit complex. You place a net label here. That is what you typically do. Okay, you place a net label and you say that this is ground, and you click connect here, and you also place a net label here which is ground. So what this do is this makes this connection proper, and these connections are the labels are local in the sense that they are not accessible outside. And this is something that you need to be aware about when you do a hierarchical schematic design in KiCad, and for that matter in almost any software or even in programming language. When you want to do a proper hierarchical system design, ensure that each blocks are well contained. The labels or the variables inside that blocks are well contained. It is not accessible to the outside blocks. So the 5 volt is accessible inside the regulator 3.3 volt, but it is not accessible outside. And only when you connect them to USB B V bus, the V bus and 5 volt gets connected. Without this connection in the root page, these labels remains local to these blocks. Or if there is a sub block, it should remain local to that sub block. So let us go here to the root page and run the ERC check. Yeah, so it is done. There is no errors and warnings. So what we will right now do is we just remove it and then we will do a proper connection, because since the circuit here is simple, you can do a direct connection here. Let us see if there is any more ground. Okay, so that is done, and let us save the schematic. Once more, let us try the ERC check. Yeah, it is done. So the schematic is done. So this is how you do a schematic design in a hierarchical fashion in KiCad. Thank you for listening.